In the previous topic, we talked about quantities that is related to electricity, for example, current and the potential difference. You also learn about resistivity and internal resistance. So today we're going to look at DC circuit, the direct current circuit. Okay, so those things that you learned in the previous topic will be applied here because it's related to electricity. So first of all, let's talk about some of the typical symbols that is in electrical circuit diagram. That the first one is that we have the switch, resistor. So some of the reference book might give you resistor symbol like that. That's the same thing. And then we have the rheostat, a variable resistor. And then we have ammeter, circle with an A, voltmeter with a circle with a V, and galvanometer sometimes is an arrow up right like that, or sometimes they give you a G to stand for galvanometer, which is a sensitive ammeter that shows you direction. So when the arrow is here, is the current is flowing here. When the arrow is here, the current is actually flowing here. Okay, and we have cells. Cells basically is battery, and we have potential meter, and we have thermistor. This is the temperature sensitive resistor, and we have lamp, and we have the diode, and we have LDR, light dependent resistor. So this is about light, this is about temperature. Okay, so the first thing, Kirchhoff law. You might not have heard this before, but this is an important one because sometimes in complicated circuit, for example, the one given below here, so this sounds crazy, right? And what we can see is that we have many loops of the connection with some multiple amount of multiple batteries. So these are all the batteries. So when all these batteries are put together to give electricity to a circuit or components in the circuit, that become very complicated because you cannot use the usual Ohm's law just like that, because they will all contribute to the potential difference and the current. Okay, so therefore there's this Kirchhoff law. So Kirchhoff, there are two laws. First one is called the first law. Second, of course, is called the second law. Okay, so it's that simple. First law, what's that about? That is, if you have a circuit, the total current flowing into a junction is equal to the total current flowing out of it. So I give you an example of the diagram here. We have a junction here and a part of a circuit. So that's a junction there where current I1 flow into that. So what comes out as 2 and 3, I2 and I3, that 2, when you add together, must be also equal to I1. So I1 equals to I2 plus I3. So we can also say that is the algebraic sum of the currents at a junction of a circuit is 0. Okay, so that's the Kirchhoff first law. Total current flowing in equals to total current flowing out. Algebraic sum is 0. You can also say that. Okay, so basically it's a law of conservation of charge. Imagine that the current inside there, we say that is the rate of flow of the charge. So there are a lot of electrons that's bringing the energy to that junction, and therefore when they come out of that junction, when they flow past of that junction, they should be equal in amount also when they break into I2 and I3. So that's the Kirchhoff's first law. Alright, so we move on to Kirchhoff's second law. Kirchhoff's second law says that in any closed loop in the sense of the circuit is closed, there's no open junction, the algebraic sum of the EMF is equal to the algebraic sum of the PD. So algebraic here means that it is sign sensitive. So sometimes it's positive and sometimes it's sensitive. So we have total EMF equals to total PD. In the topic, when you learn about these two quantities, you know that it is energy per unit charge. So it's the energy that is carried from the battery, the EMF, then this dissipated at the components or the internal resistance. So those energy, they actually must be conserved. So whatever that's supplied by the battery must be dissipated through the whole circuit. So it's a lot of conservation of energy. All right, so knowing this, in the next video we're going to look at how to apply the first law and the second law in solving a circuit problem. All right.